Welcome to the homework help video for problem 8-40 from the H8-1 D2 homework assignment. For this one, the directions state, consider the graphs of the following types of functions. Which functions are polynomial functions? Explain your reasoning. So we are looking at which of these are polynomial functions. And we already talked about a little bit earlier in a previous homework assignment. We talked about polynomial functions, or what are polynomials, and we said polynomials are expressions or functions in which every term can be written in the following form. We can have any number times x raised to a whole number power. So it doesn't matter what the coefficient is, as long as we could write it with an x raised to a power of, and that could be like 0, 1, 2, 3, and so on. Actually, I'm going to make that a set. Okay, so that's what our whole numbers are. So in this case here, like parabolas, when we think about these, when you don't have it in factored form, when it's in standard form, you usually see something like this: x squared plus 5x plus 6. Right? So we know that parabolas can be written as polynomials. So this one definitely works. Remember, 6 is like 6 times x to the power of 0. So if you're thinking about that constant term. When we look at b, an exponential, right? An exponential would look something like y is equal to 2 to the power of x. And this already does not meet this definition down here because we cannot have x up in the exponent. So in this case here, exponentials are not polynomial functions. Cubics, definitely. We could say y is equal to x to the third, right? Let's say even like minus 1, if you just wanted an example. Okay, so because each term can be written in this form down here, we know that cubics are polynomial functions. Lines. Let's think about our most basic line, right? Y is equal to x, right? That makes sense, right? It's like x to the first power, or you could add a y-intercept, say like plus 2. That still meets our definition down here. Each term is some coefficient times x to a whole number power. So in this case then, lines are polynomial functions. And then circles. Well, I'm going to tell you right now, circles aren't even functions, are they? Right? Because if I took it and I had a circle, and if I did my vertical line test, right, I have one input that has 2 different outputs. Therefore, it is not even a function. So we cannot do circles as polynomial functions. So in this case here, no, circles do not work. So the 3 that we can write would be A, parabolas, C, cubics, and D, lines. If you have additional questions about this, please make sure you reach out. Otherwise, thanks for watching.